This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So yesterday we were trying to talk about the Terraform and its some options around the Terraform, right? So we talked about how do you make some loops, conditions, some data sources, and even the provisioners. Okay, so we'll try to talk about that, right? And we have a layout now. Okay, so we know what to do basically, right? So we are going to ultimately build this particular architecture. This is the architecture we're actually planning to build here. And so to build this, basically the first thing is the network part. So we're going to make the VPC and we do that. Okay. And even before to that, so we want to talk about a certain practices of Terraform basically. So how do we want to so set the standard here? Okay, so let me show you that. Just give me 1 minute. Yeah, sorry. Hope you are able to see my screen. Yeah. Okay. All right. So what is the best what is the best practices we're going to talk about here is we're going to okay, so group the resources based on the requirement. So that's what we're going to do, and modularize the code into small pieces. How much small piece we can make it, we can do that. And also modularize will help in enterprise organizations on controlling the access of what resources you're supposed to run. So what is that means is, so in certain organizations, you will not do the complete AWS effort. Okay, so you'll be doing only some pieces of the effort. So some pieces will be done by other people. So modularizing will help you even in so achieving that also. So certain people need only certain access. So that kind of so we also like I have some Terraform code. Like let's say I deal with only with the network, so I'll be having a network access, and I'll be dealing with the network through the code. And other people having some EC2 level access, they will try to they will try to do with their code basically, and they have only that limited access. I don't need to really combine those. So I don't need to really have the whole administrator access also. So that's that way also. So this Terraform, so Terraform best practices would come into picture. And what I wanted to talk about majorly here is, so how to structure our code. Okay, so so how do you want to make the project structure code? And it has to look same for every component. You should not have some jumbling. Okay, that's also quite important. Why? Because it should not cause confusion. Okay, so tomorrow it should not cause you any kind of confusion. So what is happening here? So that's a quite important thing. So that is the reason. So you try to decide, so what kind of structure we want to make it. Okay, so so let's try to make that. Okay, so you can make it in multiple ways. So probably you will be having a, like let's say VPC as one directory. Inside that you are going to have some start.tf files. Okay, so like whatever it is, VPC subnet.tf, some .tf.tf.tf, you can have some files. And so what else you can have? So you'll be having that, so provider.tf. So probably so you will be having so some provider information. So the provider.tf, some state.tf. Okay, so having some Terraform state file information, so centralized state. And what else we can have? Some dev.tf vars. Okay, prod.tf vars, something like that. Prod.tf vars. So something like this, you'll be doing it. And also you will be having some backend information. So your state file. Also, if you want to parameterize, so that means a dev state.tf file and prod-state.tf file, not tf vars file. Okay, tf vars files. So something like this. Okay, so you can start making the code accordingly. If you have some make file also, you will be if you have some make file also, you have some make file here itself. Okay, so yeah, so generally, okay, so whatever you have, you can just have something here. All right, so that's the idea of the code structure. So the same code structure, you can make it in another way also, like simpler. Okay, so a little simpler. So what is a little simpler way basically is, so this is related to the environment, right? So probably what you can do is you can create a directory. So basically something like env, and inside env, so what you can say this as this one. Okay, and probably you can say that this is a backend configuration. Okay, any name your choice. Okay, inside backend you can move these files. Okay, like this. I can organize this also. And probably so you can also do in another way. I think the other way is a quite difficult, I mean unnecessary thing. Forget about that. So how do you organize your code is important. How do you organize your code is a quite important thing. Then how do you organize here? So you can go and put it everything in one directory, or you take little advantage of putting some other subdirectories, and inside that also you can keep it, and all you tell is your make file, you're going to tell the appropriate directory, or if it is a direct one, that's it. Make file will take care of that. Okay, so you just mention it one time and you're done. Okay, so this is the idea. So if you go with another module, like let's say EC2 is another one, so it is EC2 also, everything is going to be there, same as is. That star.tf will change because yeah, every resource has its own module. So on that particular perspective only it will change. Otherwise, it's all same. So clear? Any questions? So like not question, basically now which approach we want to go with. So shall we go with the second one or first one? Any thoughts? So shall we go with the second model, second structure, second one? Is everyone okay for second one? Anything is okay. So how do you structure a code is matters, but maintain uniformity across. That's the only suggestion which is made. Okay, which can be made. Okay, otherwise anything is okay. Okay, but keep in mind. So and yeah, so we'll start doing this. So what is the star.tf means? Star means I just mentioned, like so like let's say vpc.tf or let's say subnet.tf. So rather than just making it the file names, I just mentioned it as star.tf. That's it. So it's not the file name, basically just notating star means all files, anything ending with .tf or related to the VPC. Okay, cool. So yeah, so I think we can start making the code basically, right? And so making the code, I don't want to put it the code anymore in GitHub. I will start using my Azure DevOps directly. One second. Still going on. So repos here. So if you, I think every one of you know this P53, this one, right? So if you open this URL, I think you're opening the Azure DevOps. If you open this, it's actually directly opening here. So here also you have repos. Okay, I'm starting keeping the code over here. Okay, and on the top you'll be having the list of repositories. You can, whichever the repository you want to go with, you can go into that. I think every one of you is already having access also, if I'm not wrong. But yeah, let me just cross check. Okay, it started giving access. If access is not there also, so after a minute or so, you'll see that access. Okay, so now you can just see all these particular repos. Okay, and from here, I just want to, so I just want to put everything over here, so I can go with GitHub. It doesn't really matter anywhere. Okay, so I just want to use one place rather than going with multiple places. That's the only idea. And the second thing here is, so we already have some shell scripting. Already mentioned it under. Already have some shell script. I already mentioned it under what we call them. GitHub. Okay, I will just copy those things also here. I'll just say and I'll say shell scripting. Okay. Okay, so you can see all the files, and the same way I will say in your repository, this also I'll go for Terraform. You can also use your Azure DevOps account, and you can keep the code here also, no problem. But I prefer you to go with GitHub basically. I told you why, the reasons, right? So which is fine. And even I'll plan something to sync even the repositories, whatever is created in Azure DevOps. I'll try to put it in the same GitHub also. I can do that. So GitHub. Done. You see this code also here. All right. And yeah, so now I'm going to make the Terraform. And so this Terraform code, and technically talking about, my Terraform code should work for every environment. Okay, so what is this every environment? Okay, so in companies, you're going to have multiple environments. The Terraform code, which I write it, so technically should work for every environment. Okay, so how do I make it? So basically, rename, so environment, so environments. So usually in the organization, you're going to have the dev environment. So you're going to have everything of whatever the diagram, whatever you have seen here, right? All these components in this particular one environment. And after this environment, so you'll be having a kind of a QA environment. So you probably will have QA environment. And after QA, so you're going to have some kind of pre-prod or UAT, whatever you call it as. You will be having that environment as well. And finally, you're going to take this to the production. So this is the idea. Okay. This is how the organizations work. Okay, and you'll be having different environment for different purpose. So the devs will check, QS will check. UAT basically before production, whether the things are really working or not. So we check the functionality. Some testing can be done here. So that's where we'll be using this. And finally, you'll be having the product line. So this is a line basically how it goes. Now, if I write the code, so it should work for any environment. So that is quite important. Okay, but in our lab, actually, so this is a real-time scenario. So probably in the lab, so what I'll do is, so this is real time. Real time, you'll be having a multiple environments. Okay, but I cannot afford that much, right? So since we're a lab kind of thing, so we cannot afford these many environments to run in parallel. Okay, so in lab, I'll just dilute 2 more environments. Okay, I'll just put it to 2 environments. So one is prod, and other one I'll call it as dev. That's it. Only 2 environments I'm going to assume. But it doesn't really matter. You can scale it up to a number of environments, however you want to make it. You can make it. But we always try to make the identical code. Whatever is there for dev environment, the same thing will be used to the
production environment. So now our code also, like the developer, whatever the code he make it, that goes from the dev environment to the production environment. The Terraform code, which I write it for the environment also, for the dev environment, whatever I write it, the same code will be promoted to the production environment. So that's the idea. Okay, you cannot directly make some changes on the production, something like that. Okay, so it always has to go through the code, and the code will properly tested in the dev environment, and the prod environment we are going to just run the same thing. Okay, so that's where your development, you'll spend more time on the developing the things and standardizing things here, and you simply run the things here. So okay, so that saves a lot of cost. That saves a lot of cost. When you talk about the cost strategy, lesser the operations. Okay, so okay, lesser the operations, and so basically lesser the cost. Okay, lesser the cost of maintenance, or lesser the cost, basically lesser the maintenance, lesser the cost. Okay, that's the idea. So that is where bigger organizations like so you take Apple, you take Netflix, okay, certain organizations, right? You take Amazon of certain wing, okay, so they do so they do the developers only. They'll try to kind of do their own operations, okay, because they do a lot of development. 90-95% of work actually they do on the development only, and in the production they'll just operate it, that's it. Okay, and ensure that no issue will happen on the production. So that's the approach, basically, just to save the cost. The major factor out there is save the cost. And I think if you open the Netflix any technical conferences, they will say that we hardly have so 10 engineers so who is working, but they have hundreds of developers. They have hundreds of developers, but their engineers are less to single digit, basically. Okay, how they were able to achieve that? So because the okay, the things whatever can be done by so can be done on the more on the development side rather than on the operation side. So that's where the strategy come into picture. So which I think I've been talking about this particular word from quite some time. So immutable infrastructure. So that means you never touch the server if you want to modify. So VM refers to the VM, so that's okay. And that are never modified after the deployment. So after the deployment, I never touch those machines. If I want to touch, I will destroy the machine and I'll create a new machine with a new configuration. I never go and touch the same machine again and again. Okay, so that's the idea. All right, and yeah, so we are going to achieve this now, and so achieve basically multiple environment, and the code whatever we written usually so should work for all the environment. So that's what you have to keep in mind. All right, now let's come back to the Terraform structure, and I'm going to come to repository, and I'm saying it's a Terraform for VPC. Okay, so create it. Okay, here is my code. Now here I want to make so probably as we discussed about second thing. So here you're going to make two directories, env, and another directory is backend directory. It's going to be backend. All right. So this is how we make it. And the next thing is no more new directories. So here we're going to have two environments, right? So we are just going to make the dev.tfs and also dev.tfs. All right. And so here in the main code, so I'm going to make some vpc.tf, so the main code. And so probably here I'll make some provider, so provider.tf. Okay, and provider.tf, and then also provider AWS, and then region is equal to US-east, US East 1. Okay, we're using North Virginia. Then, and I'm going to go for a new file, and it's actually going to be is state.tf, state.tf. So state.tf is actually going to be some so Terraform and backend is S3. Okay, I'm just telling this much. And all the components inside this, I think we already made this, all right? So you can go with the remote state and remote.tf. So all these values, you're just giving only this much, S3 only. All these values come from the variables now in the backend. So you're going to have from this here. All right. So the bucket is actually D53 Terraform state files, okay. And key is nothing but where you want to store it. So key is actually going to be VPC, and it's actually a dev environment. So dev that Terraform state file, and it is east one, and DynamoDB table is also correct. Okay, done, and state is done. And probably I'll make some make file. So I will just say that so make file. So makefile, how do I use makefile? I already shown you that, in the shell scripting, how do you use your makefile? Okay, so something like this, but probably preferably, okay, I want to do little enhancements to my, if I just put this way, so then I'll not get the help message. So, so I would put another stage, another step actually over here, and I'm going to call it as, help. Okay, and I want to keep that. So help. Okay, now this will help in so this will help in what we call printing the help message. So here there is a help message given. So Terraform init for dev environment, Terraform apply for dev environment, Terraform destroy for dev environment. And so over here, if you give make help, automatically it is going to give you this particular so step name and its message. Basically, that's the idea. So that's what this grep command is actually doing. All right. And so the next one is, here. Backend config is actually not under environment variables. It's actually going to be under backend / dev.tfs. Okay, this is what I have here. Okay, so here we have env / dev.tfs. So here also we have env / dev.tfs. For production also, I'll make prod-init, prod-apply, prod-destroy. Okay, so that's the idea. So it's going to be common for everywhere. So that's where I'm putting prod, putting prod, and it's going to be prod. That's it. All right, cool. Yeah. So now push this much, and I want to test it on my workstation box. Okay, let's go to our account. And so now if I just go and give make, then what's going to happen is so if I just give make, so you see this help is going to show this help dev apply what's actually going to do, so something like this, dev destroy. All right, so dev is actually going to be not this one, dev destroy, and so dev destroy. All right, so yeah, this is how you're going to so this is how you're actually going to do the things. So it's basically okay. So this is the idea, and whatever the make option I give, and make will perform that particular steps. All I need to do is now run the code. Now run the code. So I want to run the code every time on my Linux box, every time on my workstation. No, I am not actually comfortable for this. So that's where I want to take the help of Azure DevOps only. Azure DevOps has something called as releases. Okay, so where it's a release pipeline. So what you're doing, you're releasing the infra to the environment. So that I can just go with the releases. All right, and how do I do that? So I will just come to the here you have something called as a new pipeline. Okay, I'm going to build a pipeline. So pipeline is nothing but it's a pipeline is basically a view, right? Pipeline is nothing but a view. Okay, so pipeline is nothing but a view. Exactly talking about. So pipeline means pipeline is nothing but a view. You're going to have certain so connections and dots in between. You see this, something like this. You have something, you have something here like that. So yeah, so that's a view basically. Okay, you'll be having some frequent I mean at a certain point you will have some connection. This is a different pipe, that's a different pipe. They're actually connecting them, that's becomes a pipeline, isn't it? Okay, so pipeline, if I say on DevOps, if I just give this, now your steps are going to be something like this. Okay, so one after one, you'll be doing it. Okay, so one after one, you'll be doing it. That's it, nothing more than that. Okay, it's nothing more than that. So now what I wanted to do is I want to create a pipeline. Okay, so it's a pipeline. So I'll go to the pipeline and I'll say that this is a VPC setup. Now here, what you need to do is on the top, you have something called as empty job. So you can choose empty job because yeah, you don't have anything here, or you never created any job yourself also. You can go for empty job. Okay, so let it keep it as empty. And so this one I'm going to call it as in dev environment. I'm making it. Okay, so this is one thing. Okay, so this is the new pipeline. So this is actually going to be his VPC. And just save it. All right. Now, so I need to run the code. So if I just click on this one job, 0 task, then I can go ahead and choose the agent. So the agent actually you're choosing is Azure Pipelines only. And you can ask the environment of Ubuntu. Go for Ubuntu 18 is fine. Ubuntu 20 is also fine, but some certain cases Ubuntu 20 will fail. But for now, Ubuntu 20 is also fine. Latest version is also fine. Okay, click on save. So that means you chosen the agent. When you try to go ahead and run this pipeline, so you have a VPC now. If you just say that you are creating a release, go with create release, and so you can click on that, and this is the release, and you can click on this 0%, it will go and finalize the job. So this release does nothing. You did nothing basically. Now I have to go and say that I want to do some makefile. I wanted to do some makefile. Okay, so now what I'm going to do is, so where is the code for this? Where is the feed for this? Okay, so where is, in order to run these stages basically, and so it requires some source. Okay, that's where add source is build no Azure repos or GitHub. You can directly choose GitHub also. If you want to choose a service, I mean, you can just click on new connection, then it will take to the connection and make it. Okay, you can just simply on the UI you can make it. But whereas I'll go to the Azure repos and I will start with DevOps B53 repos, and I'll start with VPC, Terraform VPC. And what is the branch you want to choose is the main branch. What is this branch we'll talk about in a bit later. So add, and you got this VPC code. Okay. Now what you're going to do is I'm going to the dev inside dev. So first thing what I have to do is this is the new agent. It doesn't have a Terraform. Okay. So then I'm going to search for Terraform. Then Terraform tool installer come into picture. If Terraform tool installer for you, it will not come into picture. It will show in the marketplace. If it is marketplace, click on get it for free. You will get it for free. Okay, Terraform tool installer. Then after doing that, you will find out this. So this is important. So for me, in my account, I already installed this particular Terraform tool installer. It will never show me that. Otherwise, it will just show me get it for free. You click on that and accept it, and it's gonna work. And what is the so what is the version we are using? The 14.3. Okay, so that's the Terraform version we asked to install, and my pipeline is will go and start installing that. Okay, so after installing that, so what I want to run is I want to run a couple of bash commands basically. Okay, so I just want to give something called as I want to say that I want to go with make command. That's it. Make space help for an example. Okay, make space help is what I want to give, and I want to run this inside a directory. Go into the advanced and choose so which directory you want to run inside this. So Terraform VPC, inside Terraform VPC I want to run make help. That's it. Quite simple only, right? It's not really so Terraform apply. Okay, now you can go for create a release. Now you actually told what to do. Now it goes and gather the artifacts, click on this dev, go inside. So instead of this Azure DevOps, I can impose Jenkins also. I can use Jenkins. Jenkins also will have some kind of UI. You click on that, check, choose the source repository, what are the steps you want to perform, and it does the same thing. Okay, end of the day. So now it actually ran. So Terraform apply make is actually giving you an output saying that you use dev apply, you get this, so let's try you get this, something like that. It's actually showing. All right. So yeah, cool. Now my bare structure is ready. So now I wanted to go with actual commands. Okay, go to the pipeline, edit the pipeline, and go inside this instead of make this one. So make space dev hyphen init, make space dev hyphen apply. Create a release, create it. So something is a failure, that's okay. Then what is a failure here? So here what it is telling is error configuring backend, no valid credential sources found. Yes. Do you have configured the access key and secret key? Because Terraform uses access key and secret key in the workstation, you already configured them. That's where it was working fine. But here it will not work. Okay. So that's where I wanted to go with that's where I wanted to go and configure some variables. How do I do a configuring the variables is that I'll go to the variables and then configure here. But is the variables related to only to the VPC? No, the variables which I'm going to put out that information is actually for the whole lot of pipelines. Okay, a lot of pipelines will use the same credential. So that's where I want to go with the library. I want to go with the library and create a variable group. And the variable group I'm saying that it has so AWS hyphen dev. And over here, and I want to put, so AWS environment variables, and you go with this. See, your Terraform your AWS CLI, basically, if you give AWS S3 LS, it will look for the credentials which is already configured, or else what it will also do is it will also use the environment variables. If these variables are also set it up, it pick the username and password also from here. Okay, so those variables I want to use it here, and those variables are this, and the other variable is this. Okay, access key ID and secret key. So access key ID, I can get it from my local system. So cat dot slash AWS credentials. So here's a file, you'll be having those credentials which you already hard coded. And the next one is this, and I bring it here. And these are simply secrets basically. Okay, I want to put it as a secret. I want to put it as a secret because I gave you the access to my repository. You can view my you can view my credentials basically. If you are viewing my credentials, so then there's no those are nowhere safe. So that's where I just log them. All right. So yeah, fine. And now I'll go back to the releases. Now I'll link that particular variable group to my go to the variables, and there's a variable group. Link a variable group. So there's a AWS Dev, and the scope is to this release or stages basically the whole release I want to say, and link it. Now my pipeline can start reading those environment variables, but you're not done yet. So what you have to do is you have to also go and declare the environment variables here, because you declare those variables as you declare those particular variables as secrets. So since you declare those particular variables as secrets, this Azure DevOps actually expects an environment variable to be passed to that particular step also. Okay, so this one and the same variable. So how do you access the variable in Azure DevOps is a dollar and in the normal braces. Okay, to give flower braces. So this is Azure DevOps. It's not shell scripting. So they expect the variable to be in that way. Okay. Done. Save and create a release. Create it. Go inside the release. Okay, cool. You see this Terraform init is trying to do this something after that, and Terraform apply doesn't have anything to do, so it will not do anything. Okay. Okay. The next thing is so no more running that in the workstation. If I want to run, I'll create a release. Okay. So that's the idea. And the next thing is I want to start making some content. So I want to in VPC. So what is the basic one? We want to create a VPC, and as per our structure here, our VPC is actually going to be is 192.168.0.0 by 24. Okay. Now go to the Terraform documentation, registry.terraform.io. Here is where you'll find out all the resources and browse providers, and AWS is the one. And go to the documentation and you'll find out VPC. Okay, VPC. And so here you'll find out AWS underscore VPC. Let's create one VPC. And how do you create VPC is this is the one they're telling. So here, and I put it here. But actually, I cannot actually hard code this content here. Why? Because it's environment specific. And what I'm going to do is var.vpc underscore CIDR. Okay, so this variable needs, and so here new file vars.tf I'm calling it as. So variable, and it's an empty variable to declare it here. It's an empty variable, and I'm going to pick that particular value from environment. So is equal to 192.168.0.0 by 24. Okay. So now you create one VPC. So if I want to test that code is working or not, so I'll go to the VPC and I'll say here get a release, create it. Now if you feel bored that every time actually you are actually going and clicking on create release, then only it will run. Rather than that, if any change comes to the code also, if you want to auto trigger also, it is possible. It is possible. So how do I do that is go to the pipeline and say that edit pipeline. So you have to go to the VPC, this one. So here there is a trigger button, you see this. So if I say that, trigger is enabled, okay, and save it, then automatically, if any code changes to this VPC, Terraform VPC code, automatically triggers the pipeline. You don't need to do that anymore. Let's see. So let it run first. So it's actually VPC is getting created. Now you go to the Swan and search for, go to the VPC. So you got one VPC. So earlier there was already one. Some peering connection is there. Okay, cool. So the old VPC is deleted. Now the new VPC is there. So this VPC, so the nomenclature is really important. The taggings are really important to understand what is that resource. Okay, so that's where I'll just go to the VPC and VPC, and I'll say that so tags I want to use tags, and in the tags, and I'm going to put like so the name is equal to so RoboShop RoboShop. So RoboShop I can put it as a project name. So that's where I can put it here as a project underscore name. Yeah, project underscore name is no, so RoboShop. Okay. So and environment. So this environment is actually I'm going to call it as dev. Okay. And all right, and I want to declare these particular variables, and so it comes as okay, so this much, and so accordingly I'm going to make it here inside my VPC and $var dot okay, I'm putting this. So probably you can just put like so a little bit more standards. Yeah, and environment is equal to okay. So var.env. And so probably if you want to create some more resources, some more information, that so something like so provisioned underscore by provisioned underscore by, let's say Terraform. See something, okay, so some understanding what by seeing the resource, by seeing the tags, you need to understand something about the resource. Okay, so what all the information you can add it, you can add it. Okay, but there is a white paper actually from Amazon. Okay, so what is the AWS tagging? So AWS tagging, there is a white paper from Amazon itself. You follow certain standards. So what are the how you can follow some standards and things like that? You have something. Okay. So based on these, when you work in the organization, you come up with some kind of strategy. So for every resource, these number of tags need to be really there. Okay. So yeah, how do you do that? Things like that you can just see here. And tagging also really help you in so verifying the bill based on the tags and things like that. So it really helps the persons to identify, okay, there are a lot of servers, which server is taking more, so which server is actually taking more, so billing, if you want to calculate that. So the taggings are the only option which can help you a lot actually. Okay, so yeah, the tagging, you have some white paper, if you just follow that. Okay, like this. So how do you make your better tagging? So there is a white paper. Okay, each and every resource. Okay, how can you make it? Okay, something like this. All right, so yeah, you can, whenever you find some time, so when you got a chance to decide how the tagging should be, so go through that white paper basically. All right, and so now actually you made it. Now I think, okay, so we just applied the changes automatically. The new release, past release was release 5. Now if I go back, actually release release 6 should come up automatically, or did I not push the code? I already pushed the code, it seems. Okay, and if I try to refresh, no, I didn't push the code. Yeah, now I'm pushing the code, and so now if I just go to the releases, automatically a new release happens. Release 6 automatically happen. Okay, so just click on dev. Yeah, so the modifications are done. If you go to the VPC, try to refresh. So now you can see this RoboShop Wave VPC. All right. So some cases you want to keep it all in uppercase, then you can call the upper function and you can keep that. Okay. So and you can click on this here now. The other tags also you can see it here. Provisioned by Terraform, environment is there. Yeah. Okay. All right. Cool. And so yeah, you created one VPC. Okay, the first layout. So inside that you need to create 4 subnets, isn't it? So that's the architecture we made. So, okay, so 2 for private, 2 for public. Okay, so 4, I have to cut it into 4 pieces. I have to cut it into 4 pieces. The starting piece is actually going to be 0.0 by 26, 0.64 by 26, okay, so 0.128 to 192. Now I need to create 4 subnets. I need to create 4 subnets, and the 4 subnets, first 2 subnets are actually called as private, and the next 2 subnets are called as public one. Okay, so how do I do that? So here I need to make a subnet. Okay, so I'll just go here and say resource AWS _ subnet. Okay, so automatically the CIDR block is coming, and the VPC ID is also coming, and this actually I'm going to call it as private hyphen subnets. Okay, and VPC ID is nothing but AWS VPC main.id. You're referring the attribute. Okay, automatically. Not automatically in the sense you're just pointing to the attribute. Okay, and the next one is the CIDR block. How do you use the CIDR block? I have to calculate it, and how many number of private subnets I need to make it. So the count equal to 2. Right? Okay, so and count is equal to 2. Okay, and now the CIDR block should be happening. So the CIDR block I need to calculate. I want to calculate automatically, but how can I calculate automatically? Okay, so there are inbuilt functions. You know that, right? So inbuilt functions can help you. So functions. Now inside functions you have IP functions. IP related functions, and inside that you need to call you need to calculate a subnet. So then yeah, so here is something you have as a subnet. Okay, so I want to test it out directly from here, so I can go for Terraform console. I can go here. So which is mine is actually going to be is 192.168.0.0 by 24. Okay, 42. You're getting so 32 by 28. First of all, I want to go 0 here. So 0.0 by 28. Okay, by 28 you're getting. Are we needing by 28 or by 26? I think. So we are needing by 26. Okay, by 26 would come up. So 28 is actually coming from 4. So 26 should be coming up from might be 2 or might be 6, anything, right? So 2 means, yeah, you're getting by 26. This is the first series, 192.168.0.0 by 26. So the next series I'll start iterating this number. So 1. So you get 0.64 and 2, and which is nothing but 1.128. So 3. Okay, so this is what okay, so we need to do that. So now I need to calculate this with this. With the help of this, I'm going to put a calculation here, and this is actually not a hard-coded value. It's actually var.vpc CIDR, and 2 is the standard number, but I should start with 0. So 0 is actually going to can come from count and its index. Okay, so actually going to be count.index. I'll mention. So first time it actually puts 0 here. Second iteration it puts 1 here. Okay, and the same thing, and I'm going to put it here, but little modification. But if I put again 0 here, you'll get the same CIDR, right? Isn't it? Okay, so here 0 and 1 is already consumed. So now what is other two things you should consume here? 2 and 3, right? So that means 0 plus 2 and 1 plus 2. So 2 and 3 will come here. So that's where I'm adding plus 2 intentionally here. Okay, so count has to be 2, but actually, depending on this, so two numbers should be addition, two numbers should be added. Okay, so this is the idea. And basically, if I want to make some tagging, so I will just copy something from here, and I'll say that this one, a private hyphen subnet hyphen dollar var. Not this one, count dot index +1. +1 means 0 means it will come as 1. 1 means it will come as 2. Okay, so that's the idea. So public subnet 1 and public subnet 2 it will become, and this is okay. Okay, so now let it run. See, you're just trying to add block by block, block by block, block by block, right? So adding one by one, one by one, one by one. That's it. And that's how you do it in real time as well. So one by one, you just build it up. The whole need, whatever you're trying to make it. So you'll make it everything there. Okay, cool. Now if I go and say that go to the subnets, yeah, you see this. So you're getting so RoboShop Dev private subnet 1, and it's actually 0.0.26. Subnet 2, this one, and public subnet 1, public subnet 2, right? Clear? Any questions on this so far? Whatever we made it? Any questions, confusions? Okay. Okay. The next thing is according to our diagram. So what we need to do is the next thing we have to do is, so we need to call this as a private subnet, and we need to call this as a public subnet. So how do you call them? We already talked about that, right? So we are going to attach an internet gateway to the public subnets, NAT gateway to the private subnets. Okay, that's the idea. And so also one peering connection to the default VPC. So these are the three other components we need to make it. Okay, so that's where so I'm making a new file here, and I'll say that it's basically gateways. Gateways.ef. So resource AWS underscore internet underscore gateway. Okay, IGW. So what I have to do is I have to create a internet gateway, and I want to attach to the VPC, and this is the VPC I'm going to attach. Okay, that's simple. That's it. And if I want to put some tags also, I can put it the same way, whatever I made it. So I can put the tagging here. bbc.tf. Okay, so let's see. And the next one is probably in the meantime, we can go with the NAT gateway. So while it is going on, so AWS underscore NAT gateway. So how do we create NAT gateway? You can find something here. NAT gateway is getting created. And the NAT gateway is going to use the connection of internet gateway. NAT gateway is going to use the internet connection of NAT gateway. NAT gateway is going to use the connection of internet gateway, and then it is going to solve the traffic. Okay, so how do you do that is, so here is how it looks like. Okay, so here you're going to have some, okay, so here you're going to attach internet gateway, and this internet gateway is actually so taken that actually that internet will be taken by this guy NAT gateway, and it will solve the traffic. NAT gateway. So NAT gateway, actually how NAT gateway will get the internet? It actually get the internet from this guy. Okay, all right, so that means I have to go and internet gateway, so that means it actually going to take one IP address from this particular subnet, and using that particular IP address, it actually solves the traffic to NAT gateway. So that's the idea, and I will go to and where was I? Here. So if I go here, so first of all, what you have to do is this actually you're supposed to give this information. So in NAT gateway and basically NGW, okay, allocation ID. So you need to give one, you need to give one elastic IP address. Okay, you need to reserve one elastic IP address. So how do I reserve one elastic IP address? So resource AWS underscore EIP. Okay, so EIP and NGW. Okay, and over here C is equal to true something. I have to give this way. Okay, so what I have to do is I have to reserve one IP address, and I'm saying that so it has to be under VPC. Yes, which VPC you want to specify? Just say that I'll be using under VPC. You reserve one IP address. Okay, so what is that is going to do? Let me show you. So I just commented this code. So the comments in Terraform is 2 hashes, and you select the code and you give control /, automatically it will comment those lines, and you give control /, it will uncomment the lines, again comment, and again this one, you select the block of lines and you can comment and uncomment using that. Okay, so let's see now. Okay, so that means what actually happened here now is there is so there is a IP basically. On the left side, you have an elastic IP. Now what it does is it just reserves this particular IP address. That's it, nothing more than that it does. It uses this particular IP. It just took one IP address from this particular, so in this one, and it is actually going to attach to the, it is going to, using that IP address, it's actually going to serve the traffic to the NAT gateway. Okay, so yeah, that's what it's going to be. And so probably if you want to put some tags also, you can keep it. So tags is equal to so this is NGW IP. Okay, so and after that this one, and now you got this one AWS IP, and it's actually going to be NGW, and it is ID, and the next thing is subnet ID. So which subnet I have to choose? I have to choose the subnet of AWS underscore subnet of public subnets, where you are taking the IP address from, public subnet. So dot star dot ID of first subnet I'm taking of 0. So I will just give 0. So because you created that particular subnets with count, so that means it's going to have multiple IDs. So that's where I'm giving star.id. So you're creating a list of resources, right? You're iterating the same resource and creating multiple resources here, isn't it? So here it is a little tricky part. So now you see this. So you're actually making it count, the count equal to 2. So that means it generated two IDs, not a single ID. VPC here you made it one VPC. That means ID is always .id. So you directly access it as .id. If that is creating two IDs, so then what you have to do, you have to give star.id and of 0 you have to give. Okay, so something like this you have to give, but that's not the case there, right? So it's actually directly one resource, so which is not a problem. But in our case, the subnets is actually going to be is two subnets. So that's where I had to pick first subnet. One subnet is fine for the NAT gateway, so you just go and give this particular one. And let's create the NAT gateway. NAT gateway will take little time, and NAT gateway is chargeable. Okay, it's not free in your account, even though yours is a free account. So NAT gateway is not free, so it is chargeable. So yeah, whenever you're not using, so just delete them. Don't keep them. So NAT gateway is getting created. So if I go here, try to refresh this elastic IP. So you get this is the IP address for NAT gateway, and on the left side you'll find out NAT gateways, and you'll find out the NAT gateway is getting created. And so what you're going to do, so these gateways you are going to give it to the subnets, right? You go to the subnets and you go to the route tables. That route table should have that information. That means, so first of all, what I have to do is I have to create a route tables. So here, new file, I'll say routes.tf. So I want to create two route tables. One is for public, one is for private. Okay, so resource AWS underscore route underscore table. So route table, this is actually going to be a public route table, and the VPC I'm going to give it as this. Okay, so but I don't know the resources. Okay, so here I don't know the complete attribute, so that's where I'll just give this route table, and the route table. So here is a route you're adding. Okay. I'll just do our table. Okay, so this is a one, and here internet gateway is internet gateway, and this is a public one, right? So internet gateway.igw.id. That's it. So your route table will be created, but it is not associated to the subnet yet. It is not associated. Okay, so that's where the private one also will make it, and now it's not it's not a gateway ID, it's a NAT gateway ID. So NAT gateway ID is equal to, so AWS_NAT gateway dot ngw dot id. Okay, so this also NAT gateway is created, but it's not really going to associate to the it's really not going to associate to the what we call them. It's not going to really associate to the VPC. Sorry, not VPC, any subnet basically. Okay, so I will associate that as well. Okay, so then I'll just go for a resource and AWS_route table association. Okay, route table association, this is a public one. Is actually going to be route table ID is equal to AWS_route table dot public dot id. Okay, but for which subnet? Subnet is actually going to be multiple subnets, right? Isn't it? So that's where I'm just going to give this. Actually need to run it for 2 times because route tables there are 2 subnets. I need to run it for 2 types, and I have to pick it up one by one. So first time I had to pick one subnet ID. Second time I had to pick another subnet ID. So how can you do that is with the help of another function, so which is element function. In element, like let's say you're having a list of values. Okay, you're having a list of values, like let's say 1, 2, 3. Okay, so of 0. If I just give 0, first value is going to pick. If I give 1 in the list, second value will pick it up. Okay, so if you do third value, you're going to get. Okay, so that is how this is so this is the one which it tells that so which index should be picked up. Okay, now I want to just use that particular one element of, so AWS_, now it is actually data is coming from subnet dot public subnet dot star dot id, and then it's going to be count dot index. Okay, private this both I mentioned as public, private, and here also it is private hyphen subnet. Okay, so let's see now. Now the appropriate association, so subnet should be associated with the appropriate route tables. So let's see how it works now. Cool. So now you go to the subnets and you just go and try to refresh once. Go to the private subnet and go to the route table. You see this? You're getting a NAT gateway. But NAT gateway you're getting to 10. This is a mistake. Sorry. So this actually should be 0.0.0.0.0 by 0. This has to be internet, right? So 0.0.0.0 by 0 is a change. Okay, fine. It will come up. And so now if you go to the this one. This another private one is also the same thing, and a public one, and you have internet gateway. Public one, you have internet gateway. Okay, so that's the idea. Now I think your whole VPC setup is done. Okay, other than the peering connection. So probably peering connection, we can take it up in the next session. So where is this diagram? So here is a peering connection. So the peering connection to the default VPC. So we'll add this particular part tomorrow. I think the whole VPC part is done. Quite simple only, right? We did all these particular steps manually. What we're trying to do is with Terraform, we're actually trying to automate the things. That's it. So clear? Any questions? Any questions, confusions?
So, Raghu, in this, can you hear me?
Yeah, go ahead.
The backend is, do we have that backend directory that we've created in the structure? Is that is that part of VPC or?
No, this is the state file information. So where you want to store the state of this particular, the resources which you are creating. So that's the state file information.
Okay.
So previously, I'm hard coding the data. If you go to the remote states, so remote states provider.tf, I hard coded the data here, right?
Yeah.
Yeah. So now I'm not hard coding the data. I'm picking this data and putting in a TF vars file. Why I'm doing that is because this this state file doesn't support the variables. You cannot actually put it like so slash so var.env. You cannot actually keep that. It will not work. Okay, that one disadvantage you have. So that is where I'm just picking these particular values and putting in a separate file, but it supports picking from a file. Okay, then I'll make two files for for dev. I'm keeping the dev.tf paths, and for prod I will just parameterize this and say it as prod. That's it. So that whichever the environment I'm running, I'll pick that particular file, so which is gonna run as smooth. Yeah.
Okay, and then similar like modules, you Terraform VPC, then there will be more drill down additional folder structure for other modules outside of VPC.
So here everything is VPC itself is already a small component, right? It itself is a module. It's a root module. You want to really require a sub module here,
okay.
right? So yeah, but in later some other components you'll require a module and then the additional code. Okay, I think in VPC you don't require a separate module to be created for VPC, another module. I don't think so. It's already everything is a set. Okay, so yeah, and that's a liberty I'm taking. Okay, so I'm a developer and okay, since I have some experience around the VPC, so I feel that so this is not needed. But whereas if you go for some other components like front end or other things, yes, we'll go into the modules and using modules. But now it is single module, root module. Yeah.
Okay. Thank
you. Raghu, like while creating this NAT gateways and all our subnets, we are giving this IP address slash CIDR the block structure, right? So exactly what IP range will it pick? Will that be assigned to either subnet or?
So here we already in the earlier sessions, actually, I'm not sure you were there that time, but earlier session we designed of the VPC. So, and we made a diagram, okay? So we'll be using this range for this particular project. And that's where I'm using that. Yeah. So you have to go with some prior videos actually to get that answer.
Okay.
Yeah, yeah. Yeah. Anyone? Any other questions? So I'm done with my work. So probably what I want to do is I want to do a destroy. Okay, so I want to do a destroy. So that's where I will just go and create another another pipeline, and I will say, or I will just clone this. How to clone this? So here you have some clone button. So clone this, and this is a whole destroy. So I will say destroy. This will destroy everything. So save it. And the only thing changes over here is, so here it is dev hyphen destroy. Okay, and this is also little stage actually on edit, and I'll say this is not a dev, actually this is VPC. It's actually VPC destroy. So I'll create these pipelines also in parallel. Why? Because if once I'm done with my work, if I trigger this particular pipeline, so everything will be deleted, so that there won't be any additional charges. When you want to run it, go ahead and run that and get the resources. And you don't want that, you make simultaneous pipelines to destroy the things. It will destroy. You know, to do some kind of a manual effort and worry about deletion and all. Okay, it will take care of what all it created. It just destroys all those things. Okay. Yeah. Any other questions? So pipelines, little bit start exploring this one, start using this. Okay, so because our next few more weeks will end up using the pipelines only all the time. Okay, so we end up here, we'll look into all those options which are available at least. All right, so okay, so see you in tomorrow's session then. Bye, good day.